Good evening, students. Today we are going to start the new chapter called Circle. In this chapter, we have to learn about the basic terms and definitions related to circle. Like what is circle, what is its center, what is diameter, what is chord, what is sector, what is segment, all those definitions. After that, we have to learn about the angle subtended by a chord at center and at the circumference. Then we have to learn about drawing the perpendicular from center of a circle to a chord. In next topic, we will learn about how many circle can pass through 1 point, 2 point and 3 point. Then we have to learn about drawing chords at equal distance from the center. So it is property of the chord and center, that one. And lastly, we have to learn about the cyclic quadrilateral. Okay, students, so we shall start with what is this circle. A student, you might have learned about the circle, but while I am asking the definition, many of the students are not able to tell. Many of the students are telling that circle do not have vertex, circle have blah blah. Those things are not there. So all the shapes or all the terms defined in maths or physics have certain definition. So circle is what? Circle is a moving point such that its distance from a fixed point is always constant. So understand this. You just consider a point O as a fixed point. And from this point O, take any another point P. Okay. So OP is a straight line. You just consider this straight line. Length means the line segment. Then you move this point P such that its distance from the O remains the same. Means what? The P is going to move so that its distance from O remains the same. So where it will come? It will again come like this. The another point P means P, new position of P so that its distance from the O remains the same. Another position of P so that its distance from the O remains the same. Another position of P such that its distance from the O remains the same. So this way we have to draw the path over which this P can move so that its distance from the fixed point O is always constant. You can get it is this shape is like this. Like you are in construction, we are drawing the arc. How? Keeping the center at one point and rotating the pencil. The pencil will move over a path such that its distance from the fixed point will remain constant. Okay, so this is the definition. So we shall first write the definition. So circle is what? Shape wise it appear like this. So this is the circle. Or so circle simply means the path such that its distance from a fixed point is always constant. Means O is our fixed point and consider the P is a moving point. So this distance OP is always constant, and this constant distance is called the radius. Even if you come to the another point, consider this point as Q. So this O to Q is same as that of O to P. It is also the radius. Come to another point, say A. Then you can also observe that this O to A is also fixed and same as the radius. Come to any point on this circular path or the path over which the point P is moving. Consider the new point as B. This is also radius. Okay. So this path which is formed means this path. Are you getting? This path over which the point P is moving such that its distance from the fixed point O is constant. So this constant distance is called radius, this fixed point is called center, and this path is called perimeter of circle or circumference. Okay, the length of this path. So let us define everything. So circle is the path, circle is a path. This path is sometimes also called as locus. Path formed or traced by a moving point such that its distance from a fixed point is always constant, is always constant. So in this path means this circular path, this path or locus, this is called this circle. The moving point which is tracing this or forming this path such that the condition is here its distance from a fixed point. So here distance from a fixed point, here we have two things. One is our fixed point and another one is our distance from the fixed point. So a student, the fixed point is called as the center of this circle. Center of circle. And distance from the fixed point, like here in this figure, the center is our O. And distance from the fixed point is called radius of the circle. Denoted by a small r. Okay, student. So here we can write that the fixed point is called as center O, and the fixed length means the fixed distance between the center and any point on the circular path is called radius, denoted by a small r. So this circle simply means it is the path. Now the path or the boundary is called as circumference. The boundary length or simply the path length is called what? Circumference. This is the name given, and it is commonly denoted by C. So this boundary in geometry, this boundary length or path length of any closed figure is called as what? The perimeter. So this circumference is nothing but it is same as the perimeter of the circle. So that we have to understand. The boundary length, it is the perimeter. So therefore this circumference is nothing but circumference means what? The circular boundary which is drawn in yellow here. Means this boundary only, this much. We are interested in this much. What is the length of this much path? This length, the total length, maybe 2 meter, 3 meter. So that length is called as the circumference, total boundary length. So this is nothing but this is the perimeter.
Perimeter.
Yes. And this perimeter is calculated with the help of radius. By knowing the radius, you can calculate the perimeter or the circumference. Circumference same as perimeter for in case of circle, but perimeter is the common term which is used for rectangle, triangle, all kind of figure. Okay, so a student, if you have the radius r, then the perimeter, length of perimeter can be calculated, length of perimeter of circle or length of circumference of the circle is calculated by, you have to multiply that radius with this r into radius. 2 is a number, pi is another constant irrational number that we have learned. So circumference is given by 2 pi r. It is this one. There is another thing that we will learn just in next few minutes, that the straight line passing through the center and joining one end to another, you may take any straight line, part of basically the line segment. Like here I am taking from one end to the other end. So this much length which is passing through the center, this is called diameter. Okay, this is straight length from the center to one of the end of the circle or on the boundary length, it is the radius. But when these two radius are on the same line, then this distance from one end to another, consider this as x to y. So xy length will be how much? R plus r is equals to 2r.
Wow.
This is called the diameter, denoted as d. So diameter is twice of radius. It is that relation. So this relation can be used here also. Circumference can also be written as pi into 2r, but 2r can be written as pi into d. So circumference can be written as 2 pi r or pi into d. Okay, students? So these are the ways by which the length of this circumference, boundary length of this circle, where d is 2r, means twice of radius. So here denotation are what? R denotes the radius of circle, d denotes the diameter of circle, and this diameter is twice of r, and c denotes the boundary length called circumference. So these are the things that we need to keep in mind. So the boundary length here in this case is our this boundary. Are you getting? We are interested in this one only. This will give us the boundary length. So boundary length, the circumference that we have calculated here is a representation of this boundary length. So this can be calculated. This can be calculated with the help of which thing? With the help of radius r. So if the radius r is known, then this boundary length can be calculated easily. Or diameter can also be calculated. Now the next term. Since it is a closed figure, observe circle is what? A closed figure. So wherever a figure is closed, it always encloses some area. Yes, students. So this area,
Pi r square.
how much area is enclosed, that can also be calculated. So it is a closed figure, there is no any vertex. So area enclosed, area of circle can be calculated, and it is given by pi into radius square. So area A is denoted by pi r square. This thing we need to keep in mind. This can also be written in the term of diameter, since the radius is half of the diameter, so d by 2 can be written, and there is square. Now this square is for the numerator as well as for the denominator, so it becomes pi d square divided by 4. So this area can also be written as pi d square by 4. Where again the A denotes the area of circle and R is the radius of circle, D is the diameter of circle. Students, how to the measuring area of sector, this thing we will learn in class 10th. So this formula is more useful in our class 10th. But here we have to learn about the definitions basically and understand what this mean. Now, there is another term called chord. So let us come to that. Or we can start with the arc. Chord and arc. Both we will understand together. Okay, student? Students, let us consider a circle. This is a circle with center O. On boundary, let us take 2 points, A and B. Let us take one point as A, another point as B. Okay, student. Then how we can reach from A to B? A student, some of you may move along this circumference. Okay, you are moving on this circumference. You are moving on this circumference. So while you are moving on this circumference, you are covering this curved path. So this curved path from A to B means moving along the circumference. The length is called as arc. Okay, student? So this length is your arc. Another student may think that rather than moving along this boundary, one may move the straight path from A to B. So while moving along this straight path from A to B, this straight path is called as chord. Okay? So it's so simple. Getting? So let us write the arc. Arc is what? It is part of the circumference. It's so simple. It is part of circumference. Getting a student? Like, let me draw one more figure. Consider a circle with center O. Let us take one point as A, another point as B. Then moving along this boundary, This is the arc. Now, one may move along this boundary, or the other may think that rather than moving from the downward, one may start moving from this upper boundary also. Okay, student. So both of these are arc. Whether you are moving from the bottom boundary or from the upper boundary, both of them are arc. But here, whose length is bigger and whose length is smaller? How we can determine? Here it appears that moving from A to B through the bottom one, let me take at the bottom there is one point as P, and at the top side there is another point as Q. So moving from A to B through point P is your a smaller arc. So a smaller arc is called as minor arc. So this smaller arc is called as minor arc. So keep in mind, minor arc. And arc is denoted by AB by putting a cap over it. So AB, above that you put this way, a small curve over it. But this is a smaller, so put MIN minimum, minor arc or entire minor arc. The other orange one, this boundary is larger. This is called as the major arc. And it is denoted by MAJ AB, putting the curve over AB this way. How a student we can understand it is the minor and major? So from this, for minor and major we can understand with reference to their circumference length. Students, if we are considering entire circle, so for entire circle with center O and radius R, if this R is a straight, it is forming a diameter. So if AB is the diameter, then what is this much length? It will be half of 2 pi r. So it is simply pi r, means half of circle. This half of circle is called as semicircle. So it is our half circle.
Semicircle.
Yes. This half circle is called as semicircle. And its boundary length is given by, what is the boundary length of this? Arc length AB here, it will be pi r. So in this case we are observing when AB is a diameter, whether I am considering the lower side of the arc or the upper side of the arc, both have the same length. This is also your 2 pi r by 2 only, because it is equally divided. Okay, students? So semicircle is what? The arc with diameter. So here we are observing if the arc is minor arc, in this case, its length is smaller than half of the circumference. Means its length of minor arc is smaller than pi r. And if we consider the major arc, then its length is greater than pi r, because pi r is half of the circumference. So right type of arc, one is called as the minor arc. So right, one is our minor arc. So here for this figure, let us denote this by PQ. P and Q is the diameter. So minor arc AB it is denoted as minor AB. This minor arc AB length is lesser than that of pi r. So write here arc whose length is lesser than half circumference. That arc is called as the minor arc. Means minor arc AB, its length is lesser than 2 pi r by 2, means pi r. It is this one. A student, even if we draw the circle like this, and if I am taking the point A and B now here, and then I am going to draw the two arc. One is A to B from the top one, another from A to B from the bottom one. Which one will be major and which one will be minor, students, in this case? Yes, can you tell me whether this black one or the red one, which one arc will be major and which one will be minor?
Red will be major, black will be minor.
Good. The bottom one, which is in red one, it is your major arc. So it is denoted as MA major AB. And its length is greater than pi r. But if we consider the AB from the top, it is your minor AB. And its length is lesser than pi r. So this way we have understood minor arc simply means the arc whose length is less than half of the circumference. This you have to keep in mind. Here we are observing that the center, if we join A to B, the center through a chord, the center lies to the other side. Means the center lies in major arc. That we also have to write. So write for the second one. Major arc. Here in this figure, we have the major AB. Consider O as the center, then point A and B. So from this side to this side, going this way, means from the bottom side, from this way, this is our major arc. So what is major arc? So arc length, or the arc whose length is greater than pi r. Half of the circle is called the major arc. So point number one. What is next point? Next point we are observing that if we join A to B through a chord, so the center lies in which arc? Major arc or minor arc? So center lies
Major arc.
in major
In
arc.
major arc.
Good. Center lies in major arc. Good. So this was all about the arc. How this arc length is calculated, we will learn in next class. Considering the angle made by the arc at the center, we can calculate the arc length. So arc length calculation is not in this standard. Another, let us come for the chord. So chord is nothing but it is line segment joining 2 points on the circumference. Means any 2 points, it could be at anywhere on the circumference. joining two, or any two, rather we can write any two point on circumference. Circumference of a circle. Okay, student? Means what if we consider this as a circle? So let us take a circle. Then you are free to take any point. Consider O is the center. Let us take a point P here and Q here. Join P to Q by a straight line. Basically the line segment. So here PQ is a chord. Getting a student? A student, but if it is written like this way, what is represent? What is this? If the symbol of some small bar like or curved bar is placed over PQ, yes?
Arc.
Very good. A student, then this means it is arc PQ. This may be either from the bottom side or from the top side. By that way, it could be major or minor. So this way, the chord is differentiated in denotation from the arc. Okay, student? So placing a cap over the PQ or the chord, it become arc. Okay, so be careful. Now, this P and Q may be taken like this. A student, someone may take, consider O as the center. Someone may take the point A here and the point B here. And joining this, it is found that it is passing through the center.
Longest chord.
And it is called as diameter. Okay? So,
Longest chord.
longest chord of the circle is diameter. Longest possible chord, of a circle is diameter. So you have to keep in mind. Diameter, what is the length of diameter? One side, this is 1 R, and on other side, this is other R.
square.
It is R plus R. It becomes 2R. So diameter, length of diameter is R plus R. So here AB is the diameter and it is denoted by D. It is our 2R. So that we have to keep in mind. So diameter is the longest arc or longest chord. It is longest chord that we need to keep in mind. And it is diameter is twice of R. So this is the about the chord. So how many chord can be drawn in a circle? Any number of chord.
Infinite.
Infinite. Good. So infinite chords can be drawn. Infinite means very large number. You will get tired, but that will not the end. Drawn for a circle. How is that? You can see by drawing it. Consider a circle, whatever the center may be. So one may draw, say this one is one of the chord, another may take this as other chord, another may take this as another chord, another may take this as another chord, going on so on. Another may start from this point rather than P. Another, consider A, B, C, D, so on. Another may start with this point M. He may touch any 2 point. Okay. This way, infinite number of chord means very large number of chord can be drawn, which cannot be counted. Okay, so infinite chords can be drawn for a circle. So this is all about your chord. Now there is another concept called segment. Students, wherever there is a closed figure, always the area is bounded. So this circle is a closed figure. But considering the 2 point A and B, joining A and B by a straight line, how many closed figure here form? One is the circle itself. The other person may say that AB as the chord, then this arc. So considering this much, one may consider this area. So this area on either side of the chord and the arc is called as segment. The other side, one may take this one. So this way, how many segment is formed for a circle? 2 segments. Here also we are getting one is having larger area than the other, and larger area segment is containing the center. So each of these part is the segment. So this is also a segment, and bottom one is also a segment. Then how to differentiate? To differentiate this bigger and a smaller, we are using the term major segment, for a smaller one as the minor segment. Okay, student? So segment is what? It is area bounded between chord, between a chord and it's a B bar W means it is between a chord and arc. Okay, as here we have written, this is the arc, this is the arc, this part is our chord, this straight line is our chord, and this area is our segment. Okay, student? So students, here we can also write major segment and minor segment. So what is our minor segment? Minor segment, what is the minor segment, students? How here we can define? Here we have to define in the term of area. So if we consider a circle, let me draw once again the same circle. Consider the point A and B. Joining AB directly, it is forming one of the chord, and then considering the area between this chord and one of the arc, one segment is formed. This segment may contain center or may not contain. So the segment containing the center is of larger area, and that segment is called as major segment, and the other one which is having lesser area. So area is the reference. Students, if we consider a center circle with center O and diameter, then for entire circle the area is 2. How much? Area is pi r square. So just for one of this part, the area will be half of pi r square by 2. The other for this part also pi r square by 2, means if it is the semicircle. So for semicircle, means the circle divided into equally two parts. But if it is not the diameter, in that case it have two kind of segment. One is called as the minor segment, the other one is called as the major segment. So here we can define minor segment. Minor segment is the segment having area, how much? How much area it have? Lesser than the area of semicircle. Lesser than only it will be smaller. Otherwise, if it is equal, then it becomes a semicircle again. So area lesser than that of semicircle. So for minor segment, we can write area of minor segment is less than pi r square by 2. Student, we have also learned this area of semicircle can also be given as pi d square by 4. R is d by 2, so it is that one. So for this arc, it should be a by 2, means it should be pi d square by 2 into 4, it become 8. So it should be lesser than pi d square by 8 or less than, in term of diameter, pi d square by 8. Sometime in MCQs it is asked. So minor segment have area lesser than, greater than pi d square by 8, pi d square by 4 or pi d square by 2. So you should be careful whenever the diameter is given and radius is given. Okay, student? Now considering the second one called as major segment. Here we are observing from this yellow region is representing the major segment. So this segment having area greater than, area of this segment or major segment greater than pi r square by 2, then it is the major segment. In which segment the center lies? Here we are observing that, yes, center lies in major segment. Now there is another term called sector. Students, if we consider a circle with center O, consider 2 points A and B. Now, if we are considering this arc, not the chord, but the other two radius which is joining the end of this arc, means consider this arc AB and the other two radius. These are our radius, R and R. So now if we are considering this arc and the two radius, again it is a closed figure, then whatever this area formed here, this area is called as sector. Are you getting? So it is area bounded by an arc and the two radius and the two radius joining the end of the arc, joining the ends of the arc. It is this one. Okay, student? So it is called as your sector. Like here it is this sector. But one of you may think, why I shall consider for the smaller one? Why not bigger one? Center O, A and B. If one is thinking for this one, consider for this one. Surely this is also another sector. So all of these are the sector. Getting a student? So sector can again be of the major type and minor type. Getting? So student, this one is called as minor sector. And this one is called as major sector. Again, here we can get that for the major sector, the area will be greater than half of pi r square. For minor sector, it will be lesser than half of the area of circle. So that is applicable for the segment as well as the sector. But the difference is that here we need to take the two radius and the arc. Okay, student? It is important. But for the segment, it was the chord and the arc. That makes difference. So right here also minor sector. So in this case, we are observing that the angle between the radius is less than 180 degree. But for this major arc, what we are observing, the angle theta greater than 180 degree. 180 degree means it should be a straight one, but it is more than that. So that's why for the major sector, the angle at the center is greater than pi. So in the term of angle, it is given. So right, minor sector, angle between two radius. Where the angle between two radius is formed, students, it is always formed at center, is less than 180 degree, or also written as pi radian. Also for the minor arc, area is less than pi r square by 2. Another one is called as the major. So for major sector, we have to keep in mind angle between radius is greater than 180 degree. If it is equal, then it becomes a semicircle. Are we okay? Because if it is equal, means it is exactly like this, two A and B. Again, this angle and these two angles are equal. So it is our 180 degree. So in this case, for the semicircle, even this sector, the two sector are of of same area, and angle is 180 on each of these sides. So for major sector here, the angle is greater than 180 degree. It is one thing. And another one, area is also greater than pi r square by 2, means half of the semicircle. So this was all about the basic definitions. Okay, so here students, we have learned about what is sector, how to identify the sector, what is chord, what is segment, major segment, minor segment, how to denote the chord, what is arc, how to denote the arc. These things we have learned. So these are the basic terms which we need to keep in mind always. Students, there are few other things also, circle and the other line called tangent and secant, that we will see later. Now based on this, up to this much, whatever the definition we have learned, we have this exercise, and hope all of you can do this very easily. So this is our textbook exercise. A student, you have to fill in the blanks quickly. Please tell me the answer. The center of a circle lies in of the circle, exterior or interior?
Interior.
Interior.
A student, all the points inside these are called as the interior point. So these are interior point, or let me write here also. Circle always means it is enclosing some area. So these are the interior points. If we consider any of this circle, so if we consider any point here, these are interior point or interior of the circle, and those which are outside this boundary, this circumference, they are exterior. And we are getting that center lies at the center and at the middle of this circle, and it is inside the circle, so it is interior one. Okay students, so this is first question. So the answer to this question is lies in interior. A point whose distance from the center of the circle is greater than radius, then it will be which one? Exterior. Means if the point here, the radius is r, so for this point P, the length or this O to A, so OA is greater than r, this implies A is exterior point. Okay, so interior, exterior are the only terms that we need to keep in mind. Another, the longest chord of the circle is, yes student,
Diameter.
very good,
Diameter.
it is your diameter. An arc is when the end are end of diameter. What is that?
Segment. Segment.
Yes, when its end are the ends of diameter.
Semicircle.
Good, it becomes a semicircle. When the ends are the end of diameter, then it becomes a semicircle. Okay, so semicircle. Segment of a circle is the region between, segment lies between whom to whom? Arc and
Chord.
good. It is the chord. If it is the two radius, then it become what? Sector. So circle that divide the plane on which it lies is a part. What is that? A circle
parts.
divides the plane
3 parts.
on which it lies in how many parts?
3 parts.
Good. So a
Three parts.
circle divides the plane on which it lies in how many parts it have divided?
Interior, exterior and center. 3 parts.
Good. So you can write this as the center, interior, and exterior. Basically, the 3 points you can understand the same as this one. So considering center as one, then all other are the interior. This is your center. These are interior, and these the points could be here. So it could be exterior. Okay, student. So it can be the 3 parts. True and false you can write. Line joining the center to any point on the circle is the radius of the circle. Is it okay?
True.
So line segment joining center to any point. Yes, it is true. Center to any point. It is always radius. It is basically the definition of the circle. Coming to the next. A circle has only finite number of equal chords. Is it true?
False.
False. Because I had explained you, even if this is the one length, you can take the same length as this and take it from here to here. You can take the same length from here to here. So any number of chord can be drawn, and even it may have the same length. If the circle is divided into 3 equal arcs, each is a major one. Is it true?
False. False.
Student, yes, you have divided it into 3 equal parts. Then you are getting that while dividing it into the 3 equal parts, none of them is greater than pi r. So for the measure, its length should be greater than pi r. Here it's half of the circumference length, but here it is less than, that's why it's also false. A chord of a circle which is twice as long as the radius is a diameter. Is it sahi? Yes,
True.
true. Because diameter is the longest chord, which is a straight one, and passing through the center and making 180-degree angle at the center. Sector is a region between the chord and its corresponding arc. Is it correct?
False.
Good. So it is the false. What it should be? In place of this chord, it should be 2 radius.
2 radius.
Good. So the definition I have explained, you have to apply those definitions only. Coming to the next, circle is a planar figure. Is it correct or not?
False.
Yes, it's true. Because in one plane we are drawing this circle. But if we are taking the sphere, that is 3-dimensional. That is not the planar. That I have explained in our area and volume. Okay, so this was all about this exercise. So these are very easy. You have to do it. Now let us go for the next part, another just 10 minutes, where we will learn about how many circles can be drawn through a point. So circle and tangents. Students, let us take the other. Number of circle. Number of circles. Students, if I am considering only one point P, so first we have to learn about through one point. One point. If we are considering one point P, how many circle I can draw? A student, I can draw this circle, also okay. Through this point, this circle, also okay. Another person can draw this circle, also okay. Can you draw more? Surely you can draw this circle which is passing through this point P. So any number of circle can be drawn. Okay, student? Even considering this as the bigger one, you can draw like this. Okay, student? Considering even a smaller one, you can draw like this. So through this point, how many circles can be drawn? Infinite number of circles can be drawn. Now, consider the second case. Through 2 points, Yes, students, through 2 points, how many circle can be drawn? Means we are given with 2 points. Say one is this P, another point is this Q. How many circle can be drawn? 2, 3, 4. How many? Students, you can draw this circle considering this P and Q, which is always passing through this P and Q. So this way you can draw. Another, you may take this circle also. You may take the another this circle also. All of this would be circle. So this way you can draw again infinite number of circles. Okay, student. So again infinite number of circles or not? Yes, you can draw with the different centers. You can draw infinite number of circles. A student, but the interesting one is the 3 point. Through 3 points, if we are given with the 3 points, say consider one as this P, another as this Q, another as this R. A student, in this case you can get that you will get only one circle which is able to pass through these 3 points. Okay, how to get that? For that you have to first draw the perpendicular bisector of each of these two chords. You have to join this PQ and QR. You have to draw the perpendicular of these two. How to draw perpendicular? In construction we have learned the perpendicular bisector, this one. Okay, now this point O will be equidistant from P, Q and R. With this much radius, you will observe that this will act as the radius. Then this can pass through all the 3 points. It will be something like this. Okay, students. So one and only one circle can be drawn through all these 3 points. And how to draw? First join this PQ, draw their perpendicular bisector. Join QR, draw their perpendicular bisector and observe where this perpendicular bisector is intersecting. That will give you the radius. And taking O to Q or even O to P, this will also be your radius. Or even O to R, that will be the third radius. So all these radius will be the same because all these points become equidistant. So only one circle. This is asked in MCQ. So only one circle. And how it is obtained? By obtained its center by perpendicular bisector. Bisector of two line segment. It is basically the chord that will be formed by joining these 3 points. Like here it is our PQ and QR. This will give you center O and radius R as either OP or OQ or OR. All these 3 will be equal. That is OP is equals to OQ is equals to OR. These are equal to their radius. Okay, student. So this way only one circle can be drawn. And how that can be drawn? That I have also written. It is one thing. Now another small thing.
सर लेफ्ट में ना
क्लास खत्म हो
क्या
Okay, students. Now let us consider line and a circle. Then what are the possibilities when a circle and a line is there? Then the very first possibility is that the line is not intersecting the circle. The second possibility is that this line AB is just touching at only one point of the circle. And the third possibility is that this line can cut at the 2 points. Let these 2 points where this line is cutting it be P and Q. So this is the third possibility. So in first case, we can get that no intersection or no cutting of a line and a circle. The second case we are getting line is just touching at one of the point. This point P in case 2, it is this one. There it may be possible that we can draw another tangent. Consider this as X and Y. But this XY will touch at some other point Q. So the second possibility is only one point a line is touching. That condition is called as the tangent. Means line touches circle at only one point. The third possibility is that line cuts the circle at two different points. So if there is different line, then surely there could be different chords that will be the form. Here in case 3, we are getting that line AB is crossing the circle, means passing through More than 1 point means the 2 point it can cut. So PQ is the chord which is formed. But in second case, the chord is not formed. So this case where the line is cutting the circle at 2 places, it is called as secant. So student, the secant is nothing but it is the line that cuts circle at 2 points. So such a line are called as secant. So either line is not cutting or touching, means just at single point it is touching, and from the third case it may cross at the 2 point. So student, these are with reference to line and circle. We will learn more about this tangent in our class 10. So only these are the few more definitions that we have to understand. Wherever secant is formed means a chord is formed by the secant. A student, keep in mind, this line is called as secant. This line which is touching at only 1 point, or even this line, is our tangent. But for the first case, there is no any relation between circle and this line. These are non-intersecting line and circle. So this was all about today class. I think let us stop the class here because I have to go for the class 10. Yeah, student, if you have any doubt, then please ask. No doubt? Yes, students?
No, sir.
Then we shall